So we have LeBron James. He emerged as a superstar in the National Basketball Association during his rookie season, 2003 to 2004. He maintained a consistent level of excellence over the first 16 years of his professional career, reaching the NBA Finals 8 consecutive times and winning 3 NBA championships. Sounds pretty amazing to me. The dot plot here shows the average number of points per game that LeBron scored in each of these 16 seasons. So this is his average number of points per game. So he had some pretty good games. He had some games where he scored up in the 28, 30, 31 and stuff. That's pretty awesome. LeBron's 20.9 point per game average in his rookie season stands out in red here from the rest of the distribution. Should that be an outlier? So visually speaking, would you guys say that would be an outlier? Yeah, for sure. Yeah, like it's very visually away from the rest of the data. And so the question is it truly, mathematically speaking, an outlier? And that's what we're going to figure out today. So besides serving as a measure of variability, the interquartile range, the IQR, Q3 minus Q1, is going to help us identify outliers. So here's how we're actually going to identify outliers. We're going to call an observation an outlier if it falls more than 1.5 IQRs above the third quartile or more than 1.5 IQRs below the first quartile. So a low outlier is any number that is less than Q1, quartile 1, minus 1.5 times the IQR. Anything less than that is going to be a true lower outlier. A high outlier is going to be anything that is greater than Q3 plus the 1.5 IQR. So what we're going to do here is we're going to use this 1.5 IQR rule. So we're basically going to find the IQR. We're going to multiply by 1.5. We're going to take that number and we're going to subtract it from Q1, see if anything's less than that, add it to Q3, see if anything's greater than that. And that's how we check to see if something is a true, legit outlier. So here's our data right here. Here's LeBron's data, and this is... I believe it's in order. Yep. So it's already in order for us. So we're going to identify outliers. So our first job is to find the interquartile range. That's our first job. Stop. Our first job is to find the interquartile range. So to do that, we need to first find the median. Okay. So to find the median, we're just going to count inward until we find the middle. We will find that we have two numbers that are in the middle here. These two are in the middle. So my true median is 27.15. That's the true median. Then we're going to find Q1. Okay, this shouldn't be showing yet, but anyway. Then we're going to find Q1. So I've got my median here in the middle. So now I'm going to look at the lower half of the data, and I'm going to find the median of the lower half. So if I mark out top, bottom, and then I find again that I've got two values in the middle. So I'm going to average those two values, and we get 26.5. So there's my Q1. So quartile 1 is 26.5. And now we're going to do that on the other side, and we're going to find Q3. So if we go on the other side, we've got Q3. So this is my upper half of my data. And so, okay, so these two are in the middle. And so I find that actual middle here, and that is 27.95. So that's my Q3 value, 27.95. So now I have my Q1, I have my median, and my Q3. And so what we do now is we find the IQR. The IQR is just Q3 minus Q1. So I'll take that Q3 of 27.95 and subtract Q1, which was 26.55, and I get 1.4. So the IQR is 1.4. 1.4. Everybody with me so far? Perfect. All right. Now what I'm going to do, I'm going to take that IQR of 1.4 and I'm going to multiply it by 1.5. So I'm going to multiply 1.4 times 1.5. This is doing the 1.5 IQR. So this is 1.5 IQR. So 1.4 times 1.5. So that's what we're going to do. What is 1.4 minus or times 1.5? Say it again. 2.1. All right, so this number right here, there's not a fancy name for this number. It's just literally like the 1.5 IQR number. Like there's no fancy name for it. It's just I took the IQR and multiplied by 1.5. So now I'm going to take Q1 and I'm going to subtract that 1.5 IQR. So Q1, quartile 1, was 26.55. So I'm going to take 26.55 and subtract 2.1. 26.55 and subtract 2.1. What is 26.55 minus 2.1? 24.45. 24.45. Anything less than this would be a lower outlier. So when I look at the data, do I have any numbers that are lower than 24.45? Yeah, I do. So that tells me that 20.9 is a low outlier. So 20.9 is a low outlier. It is less than that cutoff of 24.45. Now we're going to take Q3 and add the 1.5 IQR. So we've got Q3, which is 27.95. And we're going to add 2.1. So 27.95 plus 2.1. What do you get? 30 point, is it 5 or 05? 05. 05. Okay, cool. 30.05. 30.05. So are there any numbers in our data that are bigger than that? Any numbers bigger than 30.05? Yes, there is an upper outlier as well. So we have two outliers here. We have one on the lower side and one on the upper side. And so LeBron James had two outlying seasons. He had his rookie season, and then apparently that 31.4, that one was actually an outlier as well. Now that one, the 31.4, it didn't look like an outlier visually, but it actually is an outlier. So sometimes it can go either way. So that's how we identify an outlier. So the numbers that we used for the cutoffs, this 24.45 and the 30.05, those numbers are just used to identify an outlier. They're not really, used for anything else. So going forward, I won't use them again. They're just there to identify the cutoffs for outliers. So that's the 1.5 IQR rule. What do you think? It's not terrible. It's just maybe a little bit of a process, but it's not too hard, I guess. Okay. All right. So we now know what our outliers are for LeBron. Oh, I thought your data was in order. It was not. That's my bad. I'm sorry. I will that for later. Okay. So does everybody have all of that? Everybody good? Okay. Sorry about that. I thought your data was already in order, but obviously not. All right, so summarizing this data. It is important to identify outliers for a couple of different reasons. So first reason is they might be inaccurate data values. They might be inaccurate data values. Like sometimes maybe we have a typo, right? Somebody's entering in a bunch of data, there's a little bit of a typo, and they maybe put in 10.1 instead of 101. So maybe a measuring device broke, or somebody gave a silly response. Like maybe a student says that they did 30,000 minutes of homework per night. I know sometimes it probably feels like that many, but they're there just to help us identify if there's maybe a mistake. So that's one thing we can use outliers for. They can also indicate a remarkable occurrence. A remarkable occurrence. Something way outside of what's considered normal. For example, LeBron James, he scored a value that is way outside of what would be considered normal, even for his self. We just compared him to his self at this moment. So he had an outlying upper value and an outlying lower value. So it's a remarkable occurrence, something that's outside of the normal. The next thing is they can heavily influence the values of some summary statistics. Summary statistics. So the mean, the range, and the standard deviation. What do all of those have in common? What characteristic do the mean, the range, and the standard deviation have in common? They are all classified as something because of the way that they act with extreme values. Remember that word? Are they resistant or not resistant? They are not resistant. The mean, the range, and the standard deviation are all not resistant. So these outlying values, these outliers, can heavily influence my mean, my range, and my standard deviation. So identifying them and knowing that they're there are going to be very important when I am talking about these values. Okay? All right, so we can use dot plots, stem plots, histograms, all those fun things to look at data. We have used those for a while now, but there's one other kind of graph. The last graph that you guys are going to learn is called a box plot. You may have remember this from middle school as a box and whisker plot, okay? So a box plot is going to summarize the data using something called the 5-number summary. So here's what the 5-number summary consists of. It has the minimum. It has the first quartile, which is Q1. This is what goes in those blanks. The median. The third quartile, or Q3. And the maximum. Those are the 5 numbers of the 5-number summary. Minimum, Q1, median, Q3, and the maximum. And what we do is we take those 5 numbers along with our outlier information, whether or not there's outliers, and we create a box plot. A box plot is a visual representation of the 5-number summary. A box plot is the visual representation of the 5-number summary. Now, looking at this next section here, it looks like there's 7 steps to making a box plot. And it's like, I'm never going to do that. But I will tell you that it's just a lot of detail. It's not that hard. So we're going to learn or practice making a box plot. So here it is. To make a box plot, our first thing is to find the 5-number summary. So the very first thing we need to do is find the 5-number summary. If a box plot is a visual representation of the 5-number summary, I probably should have the 5-number summary. Make sense? So I need to find the 5-number summary for the distribution. So here's an example. If I had the minimum, Q1, median, Q3, and the maximum for the LeBron James data. Then I'm going to draw and label the axis. So the first step is to make the axis. Okay? You're going to want to do that before you start drawing the box. Otherwise, your boxes are always going to be off from your scale. You're going to want to scale the axis. Make sure you get from the lowest to the highest. And then you're going to want to draw your box. So the box itself goes from Q1 to Q3. Okay? That's where the box goes. Then you're going to mark the median. You're going to mark the median with a vertical line wherever it happens to be on the scale. It's always going to be inside the box. Then you're going to identify your outliers. So you'll use your 1.5 IQR rule. Usually, if I'm being honest, you've already done this probably. You've already identified where your outliers are. But that is what you're doing, is you're taking the width of the box and you're going, okay, I'm willing to give one whole box and half of the box before I call something an outlier. That's basically what you're doing. You're saying, I will go 1.5 of these boxes, and then after that, you're too far away. You're an outlier. So we identify the outliers using the 1.5 IQR rule, and then we draw our whiskers. Now, this is usually the step that people mess up on. We're going to draw lines that extend from the end of the box to the smallest and lowest data values that are not outliers. We are not going to the cutoff for outliers. We're going to the smallest and lowest data value that is not an outlier. Okay? So this lower whisker goes to the lowest number of points per game for LeBron James that was not an outlier. So that's how you make a box plot. Okay? So basically, you can see on the next page here, you can see what it looks like when you take a dot plot and put a box plot on top of it. So we've got this LeBron James data still. We've got his median. We've got his Q1, his Q3. Okay, the middle 50% is right there inside that box. Notice the whiskers go to the lowest non-outlier value and the highest non-outlier value, and then we mark those outliers with a star or something, some kind of symbol, okay? That's how we do box plots. Any questions? Okay, let's give it a try. Here's some data. Is this data in order? It is not. Okay, so we're going to do that first this time. So we're going to put this data in order. So we have Ryan and Brent. They are curious about the amount of French fries they would get in a large order from their favorite fast food restaurant, Burger King. Does anybody actually go to Burger King? I haven't been to Burger King since I was a kid. Like, wow. Anyway, whatever. I digress. They went to several different Burger King locations over a series of days and ordered a total of 14 large fries. All right. These guys have problems. The weight of each order in grams is shown here. We're going to make a box plot of this data, and then we're going to answer that question, and we'll talk about that in just a minute. So first step, we need to put this data in order. So let's put this data in order first of all. So let's see here. What is our lowest number? 152. Okay. And then, let's see, 159. Okay. And then we got 160. Okay, what's next?
163.
Perfect. And then 165. Okay. And then
167. 166.
okay, we got two 166s. So we want to make sure we have that both times. Okay, and then
168.
167. That's okay. 167. 168. 168. Two 170s. 171 and then 173. And that's it. Okay. All right, let me fix this. 152, 159, 160, 165, 166, 168, 168, 70, 170, 171, and 173. Okay, cool. So we've got our data here in order. All right, next thing. Let's find the median. So we're gonna find our 5-number summary, but our first step there is to find the median. So let's find this middle value. So 2, 1, 2, 2, 2, 2. Okay, so we've got two numbers in the middle. So the average of these two numbers is going to be our median. So what's our median? 166.5. So that's our median. Okay. I've now cut my data into half. Half on one side, half on the other. So now I'm going to find the median of the lower half. That's going to be my Q1. So let's find the median of our lower half. So 163. So that's Q1. So 163 is Q1. And then I'm going to find the median of my upper half. Okay, there it is. 170. So that's Q3. And then I have my maximum and my minimum is right there for me. So my minimum is 152. My maximum is 173. So I have my 5-number summary now. I have my minimum, Q1, median, Q3, and maximum. Now we're going to identify any outliers that we might have. So we need to find the IQR. IQR is Q3 minus Q1. So I'm going to take Q3 of 170 and subtract the 163. That'll give me the middle 50% range. And so what is 170 minus 163? 7. Okay, cool. So I'm going to now take that 7 and multiply by 1.5. So I'm going to find this 1.5 IQR number. So 1.5 times 7. And what is 1.5 times 7? 10.5. All right, so I'm going to use this number, 10.5, and I'm going to subtract it from Q1 and see if anything's less than that. And then I'm going to add it to Q3 and see if anything is higher than that. So I'm going to take Q1 and subtract that 1.5 IQR. So that would be 163 minus 10.5. And what is 163 minus 10.5? 152.5. Do we have any numbers that are less than 152.5? Just barely. So the minimum is an outlier. So basically anything less than 152.5, this would be an outlier. So 152 is an outlier. Okay, now I'm going to take Q3 and add that 1.5 IQR. Q3 was 170, and I'm going to add 10.5. That gives me 180.5. Do I have any numbers in my data greater than that? Nope. I don't have an upper outlier. Totally fine, not a big deal. Okay? Any questions on identifying the outliers? All right, now we're going to make our scale for our box plot. So I'm gonna do this just above my numbers here, just because I ran out of room below. So I'm gonna do it up here. All right, so we're gonna make our scale first. So let's see, I guess we could go 150 and maybe go by, what do y'all think? Should we go by 2s, 5s? What do you think? I guess we could go by 2. Yeah. 52, 54, 6, 60, 62. There's not a certain number you have to go by. You just kind of look at the data and see what would make sense. I could have probably gone by 5s, but it's okay. Okay. All right, so we have our scale. We always make our x-axis first. Now I'm going to put the box, which goes from Q1 to Q3. So I'm going to mark Q1 with the 163. So I'm going to find where 163 would be and put my little line. And then 170. And I'm going to create that box. So there's my IQR box. Now I'm going to mark where my median is. My median's in the middle of this box. So that would be 166.5. Now, just FYI, the median is not always going to cut the box in half. The median can be a little bit to one side or the other. Because, again, remember, these are 25% sections, so my median might be a little bit shifted. It doesn't have to be exactly symmetric. Okay, now we're going to go to our lowest, from the box, we're going to go to our lowest non-outlier value. We're not going to 152.5. We're done with those numbers. Those numbers have done their job, and we're done with them. So we're going to go to the lowest non-outlier value. What is that number? 159. Perfect. So we're going to go from the box down to 159, and that's my lower whisker. Any outliers, I'm going to mark with some sort of a special symbol like a star. So for that, I would do 152. I would put a little star there. For the upper side, there was no outlier. So I'm going to just go to the maximum because I don't have to worry about any outliers on the upper side. So that whisker is just going to go straight to the max. So I'll go from the box to 173. The only thing left is to make sure that I have labeled my axis. So what is this data about? French fry weight, right? So it was French fry weight. So the last thing I would just want to make sure I do is just label this as French fry weight. Say that. What?
How do you find the whiskers?
Okay, so for the whiskers, so from Q1, which is 163, I'm going to go down to my lowest non-outlier value. So I went to 159. I don't want to go to 152 because that's an outlier, and if I go there, I won't see it. I won't even notice it's there. So I go to my lowest non-outlier value, and mark that. Then I mark my outlier. For that upper whisker, since we didn't have an outlier, we just went all the way to the max. Cool. Any questions? Lots of steps, right? Lots of steps, but honestly, when you do this like 3 or 4 times, it's like, oh, okay, yeah, I got this. So it doesn't take long to really get the rhythm of how to do this. Everybody good? Cool. Awesome. So apparently that one trip to Burger King was very dissatisfying. Only had 152 grams of French fries. So sad. Part B says, according to the website, Burger King's large fries weigh 160 grams on average. Ryan and Brent suspect that their local Burger King restaurants may be skimping on the fries. Does the graph in Part A support their suspicion? So they're saying that it's supposed to be 160 on average, and based on our graph, what do we think that their Whataburger? See, I can't even say Burger King. Do we think that their Burger King is skimping on their fries? What do y'all think? No? Yeah, I mean, it kind of looks like 160. I mean, their Burger King, well, okay. Their Burger King seems like they're giving them more than they should, right? So, I mean, it definitely looks like, from our box plot, it looks like most of the fries from this Burger King are more than 163 or 160. So we can tell like what percentage by thinking about the percentages of each section. So this lower section here, this is 25% of the data. This is 25% of the data, and this is 25% of the data. So, I mean, at least 75% of the data is more than the 160, maybe even more than that. So yeah, it looks like Ryan and Brent need to get a new hobby. They need to do something else because Burger King's doing just fine. Okay. Any questions on that? We just use the data to tell these people that they're crazy. It's so fun. All right. So we'll finish up here and we will go back to talking about and finalizing LeBron James and then comparing him to Michael Jordan here in just a second. So box plots provide a quick summary of the center and the variability of the distribution. The median is displayed as that vertical line in the center of the box, or in the center box, not in the center of the box. It shows the interquartile range. That's the length of the box. The range is the maximum minus the minimum, so that's the whole plot, including the outliers. But here's what box plots don't show, and you guys need to be a little bit careful about this. They don't show us gaps, clusters, or peaks. Box plots do not show us gaps, clusters, or peaks. Since I'm just looking at how far the distance is between each 25% section, here's what might end up happening. I might get something like this. Well, this is obviously very much bimodal, right? I've got two very clear peaks here. But when I chunk this data into 25% sections and I make it into a box plot, the box plot hides this bimodal feature. Because again, I'm just looking at how wide the 25% is. And so you would never want to look at a box plot and say, oh, it's unimodal. I don't know that. You can sometimes see the skew, however. If you look at this box plot, you can see that the median is on the right side. And so that kind of tells me that there's some data that kind of trails off on the left. And this distribution is slightly skewed to the left. You can tell that because this peak is smaller than this one. And so this is slightly left skewed, but I can't really tell that about the features of how many modes there are. So just be a little careful about that. All right, here it is. Which NBA player is the greatest of all times, LeBron James or Michael Jordan? So we've got the LeBron James data again, and then here's Michael Jordan's data. This is the data on the average points scored per game by each player in the seasons that they played through 2019, okay? And then we've got their box plots already plotted for you. So there's the LeBron James data again. Here's Michael Jordan's data. what we're going to do is compare these distributions. So we want to compare what we notice about these two guys. So what do you guys think about the shapes? Would you say that they are skewed at all or symmetric, or what do you think? Obviously we can't tell peaks, but what do you think about those shapes? So for our shape, LeBron James is approximately symmetric. Michael Jordan is a slight left skew. For our outliers, that one's pretty clear. LeBron James has two outliers, one on the lower and the upper. Michael Jordan didn't have any outlying seasons. All right, what about the center? When you're using box plots, you're going to want to definitely use the median because it's clearly marked for you. Why not use it? So what do you guys notice about the medians between these two guys? What do you guys notice about that? It's a little hard to see on the screen with that color. So there's LeBron James's median. There's Michael Jordan's median. What do you guys notice about that? How would you compare those? Easy, right? Michael Jordan's median is greater than LeBron James. Not only that, you guys, but check this out. Michael Jordan's median is as high as LeBron's upper 75% of his data. Like, just saying. So there you go. Michael Jordan's median, his median is 30.1. It's almost 3 points higher than LeBron James's median. And LeBron James only averaged more points per game in one season than Michael Jordan's median. Michael Jordan's median is higher than almost all of LeBron James' data at all. And then obviously the spread. The spread's pretty clear. Michael Jordan's spread is much higher than LeBron James's spread. So who do you guys think is the real greatest of all time between these two guys?
Jordan.
It would appear that Michael Jordan might have outscored LeBron James. So